You never feel bored. That's a new name. It means I never feel bored. Alright. Can you remind me what I said we were going to look into again as an application of maximum and minimum? I didn't use the word draw. Sketch. What's the difference between the two? Not 100% accurate and is not drawn to scale. It's just a sketch. It was an idea. And a sketch could be on any surface. Alright? Anyway, that's good to remember. Even if that's not. Well, I'm sure she will go faster. So to sketch a curve, we want to produce a figure like this. In the case of cubic, and maybe in the case of parabola, we might even have something like this. What are the important features that you think will help you to have a very, maybe not detailed but accurate sketch of a curve? What are the important features that you need?
X-intercept.
You need what? X-intercept, okay, yes.
Y-intercept.
X-intercept, Y-intercept,
Maximum. The stationary point.
stationary point, don't call them maximum, minimum. Stationary point. Is that all? I'm not saying you're right or wrong, I'm just saying is that all we should consider? Yeah, that's all. That's all. So if you know your x-intercept, you know, for your x-intercept, right? For your y-intercept, and for a stationary point, maybe this and this is not going to be the same most of the time. Once you have that, then you know how to go about your sketch. For x-intercept, how do we go about finding x-intercept? Speak louder, please.
Equate Y to C.
Equate y to be 0. So equate the equation to be 0, basically. Do we all understand that? You remember that from previous knowledge? Yeah. For y-intercepts, what do we do? Put x is 0. And for stationary points, how do we go about that?
Differentiation.
You use differentiation. So that's why we're bringing this after differentiation. Of course, with your knowledge of, there's another way of finding maximum and minimum that you have done in the past. Can somebody remind me? Completing the square. But that will be for this quadratic. In the case of cubic, that will fail. So there is need for us to have a general idea, which is why you learn calculus. So throughout this exercise, I will only adopt calculus. And when I give you the worksheet, I only need you to use the calculus method. I do not want anyone using completing the square. You've learned that maybe in Form 3 or maybe towards, Form 3 already. So I'm not bringing that now. So let's take note of this. So now we have a picture of what we need to do. Let's write. Today is 12. Last time I checked. 12, 12, 19. 13 days to Christmas. So I'm just going to say sketching graph of functions. We'll only restrict it to quadratic and cubic. And the cubic are specially selected so that you do not need to solve cubic equation by an unknown method, by a method unknown to you. So even in the case where you need to factorize, I'll give you a question that is already factorized. Because now you haven't learned how to factorize cubic equation in some cases. We call it factorization of polynomials. Anyways. So the general simple outcome is this. We want to be able to sketch graphs and indicate the important features of the graph. The major keywords which we will encounter, I just want to put that. Roots, solution, Hansen mentioned intercepts a couple of times, stationary points, I will also include axis of symmetry. I will also include axis of symmetry is applicable to the quadratic function. In case of quadratic. So these are the key. I don't know if I left something out. By intercept, I mean both x and y. So by roots and solution are the same. All right, so we're going to begin. I'll just go straight to the point with one example on quadratic and one example on cubic, and of course we'll walk through the examples together, and with that we are done with sketching. From what we mentioned earlier, to find x-intercept, everybody knows, right? To find y-intercept, everybody knows. To find the turning point, everybody knows. So basically everything we're about to do, you already know. We're just putting it together in one problem, okay? So I'm going to start by saying sketch. So the problems now. Sketch a graph of what? Y equals take that as the first one. Ready? Okay. So again, first let's get the x-intercept. For the x-intercept, we equate the equation to be 0. So here I'm working on the x-intercept. Of course, you don't have to write that. I just so you know the stages. This is just a comment for you. You don't have to write that. So for the x-intercept, I'm going to do x squared minus 6x plus 9 equal to 0. This can be factorized to be x minus 3x minus 3. Yes? Am I right?
Yeah.
So, which means the x-intercept is 3 and 3. So there is only one x-intercept, even though it's a quadratic equation. Yes? So for the y-intercept, Joey, can we see everything here?
Yes.
For the y-intercepts, we put x is equal to 0. If we put x is equal to 0, y would be 0 minus 0 plus 9, which is equal to 9. Yes?
Yes.
So we have our x-intercept and we have our y-intercept. We just need now the turning point. How many turning points do you think this has? 1. Without even going to differentiation, is this going to be a maximum, parabola, or minimum? Why do you say so? Because what is positive? Because A is positive. Because A is positive, we already know this is going to be minimum. So to get the turning point, of course you don't have to do all this, so we differentiate. I mean, you don't have to write this label. I just put it there so you know the stages. So when we differentiate, we get 2x minus 6. And at the turning point, we say 2x minus 6 is equal to 0. X will be equal to 3. Yes? Because from here, 2x will be equal to 6. Am I right?
Yeah.
So it turns at x equal to 3. Isn't that a coincidence? Can you see something there? It It actually turns at the solution.
Oh.
Because there's only one
Hold
point.
on, there's only one exponent.
And that makes sense. Because there's only one root. Remember, it's meant to touch the x-axis at the root. So take for example, you have this one. So it's meant to touch here, come down to turn, and touch another root. But this time around, there is only one root. So that makes so much sense. Okay? It touches at the root and it turns back because there's only one. So that makes so much sense. With this, we already know, because this is quadratic, you can explain that because it is quadratic, because A is negative, it is minimum. That's allowed. You are sketching. I'm not asking you to justify by differentiation why it is. You understand? So for curve sketching, that simple explanation is good. Since A, so I'm just going to say instead of doing the 2y dx squared. Okay? Since A is greater than 0, then we have minimum. I'm just going to say we have minimum. If you want to use the derivative method, you did the 2y dx squared. dy by dx is
2.
this, so the 2y dx will be 2, which is less than 0, and that also gives us minimum. So either one is fine. Now that we have all the details, now we can sketch.
Why is 2 less than 0?
Oh, sorry. Now that we have all the details, we can go ahead and sketch now. So we do not have any business with negative x-axis, isn't it? So you don't have to draw both positive and negative, basically. Do you have any business with negative y-axis? No. So because of that, I'm going to just do this. There's no point putting the others. Yes? My y-intercept is here. So it's going to be in this form. Uh-oh. Why is it afraid to touch it? It is afraid of Justin. Well, don't laugh at my sketch. It's a beautiful sketch, isn't it?
Yeah.
Beautiful sketch.
But shouldn't like your graph be like a little bit accurate or like but I'm saying like
Dude, it's a sketch.
yeah, but like shouldn't the y-intercept and like the x-intercept be like 1/3 of the y-intercept because it's 3 and 9?
You're still talking about the scale.
Yeah, I know.
I
but,
repeat
like,
again, dude, it's a sketch.
But like it's gonna look better, you know?
Alright, so what is this point? 3, 0, yes? What's this point?
0, 9.
0, 9. Alright, now. Can somebody guess what this means? Axis of symmetry. What does it mean?
The x, the
So that's
minimum
6,
point
9.
The minimum
of
point.
x.
So line of symmetry to both sides.
I didn't get that. No, like, say it again and speak louder this time.
What did I say?
It's like
You know what you said?
when you both put
Mm-hmm.
together, it just
Mm-hmm.
It's
It's
the
just
the left.
It's just the
It's
same.
symmetrical.
it's symmetrical, yes. That is a line. Okay, let's put it this way. Axis of symmetry
Line
is that line that divides the parabola into 2 equal parts. That when you fold them together, that's why she said when you fold it together, they fit. So it's looking for, if this was a shape, like a rectangle, for example, or a square, where is that line of symmetry
It's the middle.
where you can actually fold it? In the case of parabola, it's always at the point, it's always that line y is equal to, that passes through the turning point. Okay, it's always the turning point because after it turns, it's going to go the same way with the same slope on both sides. Does it make sense? So your axis of symmetry, if to be shown, will be something like this. You just do broken lines and let it cut through that. If you are asked for the equation of the axis of symmetry, does anybody know?
Y equals
X equals what?
3.
3. So the equation of the axis of symmetry or line of symmetry is x equals 3. It means that x equals 3, the parabola can be divided into 2 equal parts, which can overlap if you fold it along that x equals 3. Alright? It will fit together, I mean, not just overlap. Any question? Truth? Okay. Where did I get that from anyway? Truth. Maybe from your dad.
He just told me.
Ah, that's where I got it from. Maybe when we speak, it start from sometime and I say truth, and I just speak that. You know, easy to say truth. Instead of, there's less stress compared to say truly. Imagine the energy for the last, truly, the truth shots. The rest of the energy has gone into some math calculations.
Can you say truth?
Now, I say truth, and I use the rest of the board.
We don't need more energy on this.
Does this make sense, everyone? How about I give you one to do right now, just like this, before I go to cubing?
Yeah.
Yes? You still have time, right?
I just get
How many minutes to lunch? I'm hungry.
25.
Okay.
Stretching.
Stretching? Well, you go for stretching, good luck, I go to lunch.
Just go straight.
But we have pizza.
Oh yeah, we have.
No! I'm not invited, I'm coming.
Just the Nelson's.
Wait, is this English again?
No.
What subject this time?
People watch PSA.
No!
The
For
cat.
teaching the kids.
Yeah, people who go to Canada.
That's not fair.
I know, right?
That's so sad.
not going to catch
I want pizza too.
I'm ready for your pizza.
Alright, let's do this. Let's play with that sweet question. This one. Yeah, very sweet.
It's not sweet.
Sweet. Oh, I like that. So you work in this case. I'm trying to put my coordinates. What minutes? This is me being OCD.
May I wear my hat?
What do you mean?
I bought a Christmas hat.
In the class?
Yeah.
Okay. It's Christmas season. Please always label your curve. So here I'm going to write y equals the equation x squared minus 6x plus 9. Okay? Everybody?
Yep.
Look up. Label it. Sometimes you may want to write it here. It's fine. Look, 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 look. If you don't want to write it here, you can write it like as if it's going with the curve, something like that. Just as long as we have the equation. Okay?
No, it's way brown.
Do you want the XD ones? Do I put it in like dy dx equation or do I put it in? Okay.
We just need to put some feathers, whatever. Hello, Miss Lefty. Oh, did I just bump into the camera? Maybe. Don't worry. Hi, Giselle.
What if she doesn't match?
She's the one that asked me to bring it to class.
Oh.
Yeah. She messaged me on WeChat.
But we need to charge it from the
What?
Aren't we going
Tell me what?
If we use all the battery,
Yeah, I should.
use all
I should. Oh, so you need this tonight?
Yes.
No problem.
We need to
But
charge it.
but I need it for my Form 5 class.
Why is it fine?
My Form 5 class from 3:30 to 5:05.
That's okay. Saturday.
So after that, then I can give it to you guys.
Yes.
Yes, ma'am.
Please
I'll be in 211. I'll make sure we charge as we film Form 5 class.
Okay.
Because one of the students is not around, so she watches it from where she is.
Because we want to the references. It's the main character.
No,
Are you coming tonight?
yes, I got 2
Justin?
tickets. Justin is not coming tonight?
Of course he's the main character.
All right, I'm coming tonight. 2 tickets. I think we do roll. Yes, sir. I'm gonna check. You have to label your points. You have to label your points. Yes. You don't have to put 3, 0. You could just put 3. No bracket. So we know it's x-axis and that point is 3. Question 2? Yes. Are you telling me what it should be, Ansin? Or you are doing what I asked you to do? Why don't you just do what I asked you to do and let's talk about what it should be? Yeah, that makes much sense now. And that's your, are you sure this is -1 or -2? Okay.
Now I think.
Should it? Done? Compare with someone when you finish.
What are you doing?
This
Are we done?
Yes.
So tell me what you have. Do you have anything on the positive axis of x?
Positive.
So only negative x and positive y.
Yes.
Okay?
But also negative.
Also negative y. So something like this.
Yeah.
Yeah.
What is your y-intercept? 3. What's your x-intercept?
Negative.
So there are 2. So which means your curve is going to come this way and like that. Rita? That's what I was saying. So this is, so I could just write here -3, -1, and your axis of symmetry, x equals -2. So which means the turning point is what?
-2.
-2, -1. So this is, then you write the equation somewhere. Okay? So I write here y equals x squared
Plus 4x.
plus 4x
Plus 3.
plus 3. So this is a sketch that we do. Okay? Can I write cubic and you try first before we do it together? Yes? Okay, so let's play with this. Or maybe even higher functions. But let's start with cubic. Y equals, times this, y equals -x cubed over 3 plus 2x. Yes, I do. Quickly do that.
Hey, you got the same thing?
Yeah.
So you might be right.
But how do you find twice x squared?
So that's root 6 or something.
Yeah. So it's net plus or
But,
minus root 6 and so on.
Mm-hmm.
But then I should have 2 from the other.
Yeah, so you have to figure that out. That's why it's a cubic function. So you might have, you have one more than 1 time. Yeah?
Wait, Candy,
Then if x squared equals 6, then that should be 2 answers.
the root is 1, 0, and then root 6, right?
1, where do you get 1 from?
If you take the x out of there.
That's 0.
Oh, it is 0.
Yeah.
Okay, so it's only 0 and then root 6 then, right?
Yeah.
There are 3 values.
3 values, yeah.
So 0, 0, and root 6.
0 positive root 6.
0, negative root 6
Oh,
and
okay, yeah.
root 6.
Thank you.
So we have root 6.
So what you could do when you are trying to estimate the position of root 6 is to find the decimal equivalent. What is root 6? That's 2 point something, right? So you know it's between 2 and 3 when you draw it. But nobody knows where 2 and 3 is anyway. It's just a sketch, just write root 6. Okay?
Root 6 or negative root 6.
Okay. So just follow this. If you want to get the x-intercept, what do you do? So, have you started that? You need to get to that point before you understand what they are trying to say. How do you do this? Okay. Before then, make it simple. By what? Yeah, so what do you do? So multiply each step by 3. Function is negative 3, so first one is divided by x. Multiply by 3. So you divide by x and negative 3, so what does this become? What? Now we have the expression. Then what is the first thing to do to factorize? Good, so do that. When you have equation with fraction, the best thing to do is to get rid of the fraction. You clear the fraction by multiplying each term by the LCM of the denominator. We've used that in algebraic fraction before. So please try to remember that. 10 minutes to lunch. I'm so hungry. And 10 minutes to your sketching. No, stretching. Wait. We're doing sketching and now you're going for sketch. Oh, wait. Which one are you guys? Stretching, sketching.
No.
Yeah, whatever. Are we done? Yes. What up?
The hell is 5 minutes?
Isn't that negative x cubed?
What's your note, Sonia?
I think
So because Melody is not here, you don't have a note again.
And I think you say yeah, take out x here.
Yeah, why don't you ask me?
And you get like